Okay, we are starting chapter 5 instruction today, so we're going to talk about solving inequalities by addition and subtraction. And we're going to look at linear inequalities. It's going to be a lot like we're used to with solving linear equations, only we're going to have to keep track of what direction the inequality signs are going. We also will have a little bit of a new type of notation that we're going to worry about today. So we'll solve by addition and we'll solve by subtraction. Hold on just a second. Okay, so we will look at this. You guys know quite well how to solve the equation on the left there, x minus 3 equals 7. All you have to do to solve it is
Add 3.
Add 3 to both sides. And you would just have x equals 10, right?
Yeah.
Okay, solving a linear inequality is the same steps. You have x minus 3 is greater than 7. All you do is add 3 to both sides, and x is greater than 10. You have to keep track of the symbols and make sure that you're not changing inequality symbols to equal signs or that you're not forgetting to write them properly. So it just requires a little bit of paying attention on your part. The addition property of inequalities is stated there below. If the same number is added to each side of an inequality, then the resulting inequality is also true. So there you go. If I wanted to check this solution on this, it's not quite the same as checking this solution on an equation. To check the solution, you would choose this number, 10 minus 3 equals 7, and then we would have 7 equals 7, and that's true, right?
Yeah.
Okay, for an inequality, this tells me that x has to be greater than 10, right?
So anything greater than 10.
So choose any number greater than 10. 11. So 11 minus 3 is greater than 7. 11 minus 3 is 8, and 8 is greater than 7, and that checks. That is true. Okay, so that's the way you would check a solution with an inequality. All right, let's just look at a couple of examples here real quick. We'll also talk about a new type of notation as well. It is, oh, there it is, okay. So x minus 12 is greater than or equal to 8. So what do I do to solve it? Add 12. So x is greater than or equal to 20. All right. Now, one thing you're going to need to do on your assignment today is graph your solution on a number line. And so, I know you guys have done this before in the past, but we need to go over to refresh your memory. When you graph an inequality on a number line, there are two different symbols that you might put on the number line. You might put a circle or you might put an enclosed dot. And it has to do with whether this equal sign is here with it or not. When the equal sign is with it, which one do you use? The enclosed dot. So if I label my number line and my number here in the center is 20, I would make this one 21 and this one is 19, right? Mm-hmm. So I would put an enclosed dot at 20 because it has the equal sign, and x has to be greater than 20, so I would shade this direction. Shade greater than 20. Does that make sense? Okay, the other thing that we want to learn today is something called set builder notation. And set builder notation is just a different way of writing your solution, and it's written as a set, which sets are always written with fancy brackets, remember? And it's going to be read this way: the set of all numbers x such that x is greater than or equal to 20. That's a mouthful, but that's the way you would read that. The set of all numbers x such that x is greater than or equal to 20. And enclose that. Huh?
Do you have to write that?
You have to write that. That's set builder notation. That is set builder notation.
This was
Whoops.
practice.
I guess I clicked the wrong button yesterday.
Every answer. Wait again.
Okay, so this next one, k minus 2.9 is less than 13.8. So add 2.9. K is less than 16.7. Okay, so I always want the center number to be the number that we're graphing, 16.7, and that would make this one 16.8, and this one 16.6, right? K is less than, so what symbol goes at 16.7?
Circle.
A circle, open circle, because it does not have the equal sign, and we're shading which direction?
Left.
To the left. K is less than that, so left is less. And then set builder notation. I've got room up here. The set of all numbers k such that k is less than 16.7. And let's do this last one here. M minus 4 is less than or equal to negative 4. Add 4 to both sides. So m is less than or equal to 0. So 0's here, 1, negative 1. What symbol?
Open. No, enclosed.
Enclosed, because it's got the equal sign. If it has the equal sign, it's closed.
And you go to the left.
Shade to the left because it's less than, okay? Set builder notation looks like the set of all numbers m such that m is less than or equal to 0. All right. We also can solve equations with subtraction. Again, you guys know how to do this. H plus 6 equals 9, you would do subtract 6, and H equals 3, right?
Yeah.
Same thing with an inequality, subtract 6, and H is less than 3, okay? And again, if we were going to check this solution, choose a number that's less than 3.
2.
So 2 plus 6 is less than 9. 8 is less than 9, and that checks. Okay? Work through a few more examples. N minus 7 is greater than or equal to 4. So subtract 7, and n is greater than or equal to negative 3. Put negative 3 here, negative 2, negative 4. What symbol?
Enclosed.
Enclosed symbol. N is greater than that, so greater goes which direction?
Right.
To the right. Good. Don't let the negatives confuse you. Set builder notation looks like
And
the set of all numbers n such that n is greater than or equal to negative 3.
what?
Negative 3, right?
Oh, yeah.
B plus 12 is less than 20. Subtract 12. B is less than 8. Graph it. So what symbol goes at 8? Open circle. Shade left. Set builder. The set of all numbers B such that B is less than 8. Last one, minus 6, B is less than or equal to negative 9. Oops, I forgot to label this one 8, 9, and 7. So negative 9, negative 8, negative 10. What symbol goes at negative 9?
Enclosed.
Enclosed circle. And shade left, since it's less. All right, so set of all numbers v, such that v is less than or equal to -9. Okay, we may have a few where there are a couple of steps to solve rather than just the one step. Ah, good grief, sorry. Keep clicking off the screen. All right. The key here is that I want to make sure I end up with a single variable. So do I want to subtract 3h or subtract 4h?
Subtract 3.
Subtract 3h, thank you. Subtract 3h. And then what do I do with the 2? Subtract 2 from both sides as well. So that would be h is less than 5. Okay, and if I was going to graph it, I'd make a number line, put 5 here, 6 and 4. Open circle at 5, shade left. Okay. And same with the set, set builder would be the same. Everything's the same once you get to your solution. Just getting to the solution took an extra step. What do I want to do to start with?
Subtract 5h.
Subtract 5h. And
Minus 2. That's minus
subtract 2. So that would be -6 is greater than or equal to h. This one's backwards from what we're used to seeing. All the other examples. So -6, -5, -7. What symbol?
Close.
In closed circle,
And left. Left.
shade left.
It's left.
Who's greater than?
No, h is
No,
less than.
Yeah, H is less.
-6 is bigger than
If you
h.
flip it around, H is less than or equal
Yeah.
to
Okay.
-6.
We could rewrite this, couldn't we, as h is less than or equal to -6?
Yeah, so you go.
If you flip it, you have to flip everything. You can't just change sides like you can with an equal sign. Okay, so h is less. You have to watch out for that. If the variable ends up on the right side, that gets confusing. Okay. All right. Couple of word problems just to get some practice. I included in your notes there some of the common phrases or words that can be used for each of the symbols that you might need to think about when you're setting up your own equations or your own inequalities for word problems. So Philip needs the temperature of his gecko's basking spot to be at least 82 degrees Fahrenheit. Currently the basking spot is 62.5. That's one chilly gecko. How much warmer does the basking spot, sorry about the typo, the basking spot need to be? So I need to set up an inequality to solve. Don't just jump straight to the solution. You know that when you have a problem like this, they're always looking for you to set up an inequality or an equation to solve. So I know that I have 62.5, and I know I need to make it warmer, plus W. It needs to get higher, right? And I want it to be at least, what symbol do I need for at least?
Greater than.
Greater than or equal to 82, right? So subtract 62.5. And W is at least 19.5. I need to get at least 19.5 degrees warmer before Mr. Gecko can be happy or survive. Okay? All right, that's good. Last one here. Sandy has $65 to spend at the mall. She bought a t-shirt for $18 and a belt for $14. If Sandy wants a pair of jeans, how much can she spend? Okay, so the trick with this one is, does she have to spend all of her $65? No, she could spend less, right? So she could spend 18 plus 14 plus the cost of her jeans, and that needs to be what? Less than or equal to 65. All right? So 18 plus 14 is 32. 32 plus J is less than or equal to 65. So subtract 32, and J is
Thirty-three.
less than or equal to 33. Okay? All right. That's the type of thing you should be doing on your assignment today. Don't forget to use the set builder notation. Don't forget how to check the solutions when it asks you to do that.